Okay, hello everybody. Mr. Lau here again. Thank you for joining me back for this second lecture. All right. So hopefully everybody is doing well during this period of time. So what we are going to cover here today is the part on system of linear equations. Okay, this part actually comes together with inequalities. All right, but uh, I wouldn't say it's a small part. There's still some relevant questions that we need to discuss, and the importance of this really will only come in when we actually go into the tertiary level, meaning in the university time. So for now, we just really want to what we want to do is to understand the main concepts of forming equations and then solve them. All right, and get through our A levels. All right, Ken. So today I'm just going to quickly go through a few questions that touch on a few important concepts, and let's see how it goes. All right. Ken. So for this chapter on system of linear equations, basically we are trying to solve equations. In secondary school, we actually have some experience on this, whereby we tried to solve some simultaneous equation. So simultaneous equation in the past, we used to solve two equations with two unknowns, and there will always be a solution for it, correct? However, it's not always the case, okay, Ken? So that there's a few other possibilities that can happen, okay, when it comes to solving equations, okay, which we'll discuss here today. And of course, we are going to upgrade ourselves a bit by solving instead of two equations, we want to solve three equations. Okay, of course, this can be achieved by using our graphic calculator. Okay, so please make full use of it. What we want to really learn here today is to be able to formulate the equation and then to solve them. Okay, be it by hand or by your graphic calculator. Okay, so without further ado, maybe let's look at the first question we have over here. Uh, Let me bring out the pen. Okay, so what we have here is this Hua Zhong question. All right, so in Singapore, most household monthly utilities consist of three components. All right, water service, electrical service, gas service. Domestic potable water being charged with an extra water conservation tax at 35%. Okay, so please take note of this. Water is charged in terms of dollars per cubic meters. Electrical and gas tariffs are both charged in cents per kilowatt hour. All right, kilowatt hour itself is energy units. Okay, can so follow on. Adam and Megan and Jamie live in a 3, 4, 5 room flat. All right, and we have a few values over here. And so the electrical, water, and gas consumption, okay, for Jamie, Adam, and Megan, okay, summarized there. Okay, so in this table, we can see, all right, it summarizes the amount of water, okay, that Jamie used, Adam used, and Megan used. All right, the amount of electricity that Jamie used, Adam used, and Megan used. An amount of gas that Jamie used, Adam used, and Megan used. All right, okay, and the total amount that was paid after the rebate are also given in this table. So one important part of this chapter itself involves being able to understand the table. All right. So in this table or most of the table, what we are really looking for is how to read it, whether is it in column form or in row form. So for this case, okay, the individual consumption, all right, is summarized in a column form. So we actually read from top to bottom, downwards. All right, so we are asked to find the price of water tariffs, electrical tariffs, and gas tariffs. Okay, can so the fundamental approach to such a question is actually to use the algebraic approach. So what we are going to do very quickly is to let the water tariffs be x and let the electrical tariff be y. and let the gas tariffs be Z. Okay, this will happen for almost every single question. We will straight away set the unknown be X, Y, and Z. All right, don't read too much else into the other parts of the question. The only thing you have to do here to start off is to let the unknown be X, Y, and Z. Okay, so with that, we are going to form our equations. All right, so let's form the Jamie equation first. All right, so Jamie is going to use 16.6 cubic meters of water, so 16.6 x plus 504 y plus 72 z. All right, and this should give you 147.76. Okay, so you see why am I writing this as 147.76? How do I actually get this value over here? Let me just shift this around. Okay, so this 147.76 is actually your amount, okay, before the rebate. Okay, so you must look back into the question. All right, so in this case, Jamie actually receives $28 for the rebate. Correct. So if you use 119.76 plus 28, okay, it gives you this value over here. All right, this is the original value without the rebate. Okay, so I say again, we will use this 119.76, add it to $28 to give you this 147.76. Okay, so that's our first equation, equation number 1. Okay, next shall do the same thing. Once we get the flow right, the rest is just repetitive. So we are just going to use Adam's values, 22.2 x plus 634y plus 107 z equals to, in this case, this will be 191.51. Again, how do we get this 191.51? Very simple. We're just going to use 166 plus the rebate that was given, which is $25. Okay, so this 166.51 plus $25 should give you the amount before rebate that this Adam has to pay. Okay, and of course, the last equation here will be 26.4 x plus 723y plus 125z is equals to 221.04. Okay, again, 221.04 is 204.04 plus $17 rebate. Okay, so ladies and gentlemen, what we have here is our equation 1, 2, and 3. Okay, and so to solve this, okay, very simple. Okay, you just go to your GC, go under apps, go under PLY SMLT2. Okay, and then you go for the equation solver. In this case, the equation solver should be set at 3 unknowns and 3 equations. All right. Okay, so once you key in everything, press enter, you should get your values of x equals to 1.9227, y will be 0.20287, and z will be 0.18886. So take note over here, units for this particular chapter is important. Sometimes the question likes to play around the units. Over here, this is in terms of dollars, because the values that we use here is all in terms of dollars. Okay, but is this what they want? Okay, no, not yet, not exactly. Let's look back at the question. They want the price of the water tariffs in dollars. So don't forget, there was a 35% water tariffs. Okay, so to get the actual cost of water tariffs, okay, water, all right, you need to use 135%. Okay, 135% multiplied by your 1.9227. Okay, can? Oh, sorry, it's the other way around. Okay, because the this 35% tariffs is applied to the value already. Okay, so to get the original cost, okay, we have to divide by 130% instead. So to get the water, will be use 1.9227 divided by 1.35. Okay, so in this case, you will get $1.42 per cubic meters, so per meter cube. All right, so I say again, why we divide by 35, 1.35 is because the value here, the $1.92, is the value after the tariffs is applied. So this itself is already 135%. So we want to find out what is my 100%, which is the original cost of the water tariffs. Okay, Ken. So next for the electric. Okay, so for the electric, we want it in terms of cents. Okay, Ken. So of course you need to convert dollars to cents. So this will be 20.29 cents per kilowatt hour. All right, same thing for the last one. Okay, will be 18.9 cents per kilowatt hour. All right, so that's it for this first question. Relatively easy. A few things to take note. Okay, for now, when you look at me demonstrate the question, it might look easy, but it's a different gameplay when you sit for this in the exam. Okay, you need to maintain clarity in your mind to be able to form the three equations. Okay, so a few things to take note. All right, firstly, you must ask yourself how to read this table. In this case, the table is written, the values here, okay, is summarized in column form. So Jamie, this column, Adam, this column, Megan, this column. Okay, so that's the first thing. Second thing is, without hesitation, please let your unknown be X, Y, Z. All right, don't read too much into that question. First thing you should do is to let the unknown be X, Y, Z. All right. The last thing, of course, is your units. Please be careful of your units, what they want or what you need to apply. It must all be consistent. All right. So that's it for the first question. Okay, let's move on. Oh. Okay, let's move on to the second question. So come this, things not moving. Okay, can. Okay, so for the second question we have here, we have this Yonoa florist, okay, who ordered 612 flowers for Valentine's Day. They ordered rose for $45 a dozen, tulip for $210 each, and daisies at $150 each. Okay, and paid a total of $1,719 for the flowers. Okay, Ken, of these flowers, 120 of them could only be delivered on Valentine's Day itself. All right, this consists of 1/6 of the rose, 1/5 of the tulips, and 1/4 of the daisies. Okay, so we are asked to find the number of roses ordered. Okay, Ken. So over here, what we have is 3 types of flowers. All right, Ken. So in this case, we need to let the first thing again, we let the unknowns be the algebra. Okay, let the number of roses be X. Let the number of tulips be Y. Let the number of daisies be Z. Okay, can. So again, first step, always let the unknowns be x, y, z. In this case, there's no table. Okay, personally, I feel if without table, okay, you have to be a bit more focused. All right, you have to be a bit more vigilant in reading the question. Okay, because there's no table to summarize everything for you. Okay, so next we have to form the equations. Okay, so we have to read the questions line by line in order to form the equation. So the first thing is the florist ordered 612 flowers. So of course, the first equation to form is x plus y plus z is 612. All right, Ken. So next, they ordered roses at $45 a dozen, tulips at $210 each, and daisies at $150 each. All right, so and the total cost is 1719. So we can form the other equation using the cost. All right, so $45 a dozen for the rose. So be careful, okay, because it's in terms of sets of a dozen. So X is the number of roses. So you must use X divided by 12 to calculate the number of dozens they ordered times $45 for each dozen. All right, for tulips, it will just be 210 times Y plus daisies, which is 150 times Z. And this here will give you 1719. Okay, so this is your second equation. Okay, so the last equation, okay, is the last piece of information. 120 of them could only be delivered on Valentine's Day itself. 1/6 of the roses, 1/5 of the tulips, and 1/4 of the daisies. All right, so 1/6 of the roses plus 1/5 of the tulips plus 1/4 of the daisies will form the 120 that can only be delivered on the Valentine's Day itself. So this is your three equations. All right. Can so plug into your GC again, same thing, apps, PLL, YSMLT2, solving equations, equation 3 unknowns. Okay, type in and you should get your X to be 324, Y to be 120, Z to be 168. Therefore, the number of roses will be 324. Okay, can so this itself, why I choose this question, because this is another way the question can be presented without tables. It's just English. Okay, words, and words. All right, so but the concept remains the same. Okay, so the first thing is let the unknowns be x, y, z. Then form your equations. Take note of the units today. The units, the trick in the units lies here in $45 a dozen. So make sure you use x divided by 12 times 45. Okay, then the rest is standard. Okay, so that's it for this question. Let's move on. Every question I have to do this. Okay, it's okay. Better than nothing. Okay, so the next question, all right, the next form that they can come up with, all right, is the couple with another chapter. Okay, one of the easiest way to couple this with is actually your chapter on this equations and inequalities. All right, Ken. So over here, what we need is to solve this equation. All right. Okay, give me a minute. Let me just adjust something. Just give me a minute. Mm, uh, give me a minute. Okay, sorry. Okay, I'm back. Okay, so for again, as I mentioned, okay, the other way of presenting the question is to couple with another chapter. So over here, this question is actually coupled with your curve sketching. Okay, so we have a cubic polynomial, all right, whereby we have a x cubed plus bx squared plus cx plus d. All right, so a, b, c, d are constants that has turning points of this. Okay, so we are asked to find the equations of this polynomial. So today we have 4 unknowns, a, b, c, and d. So our objective, very simple, we have to form 4 equations. Okay, using the stuff that is given to us. All right, so what can we do? Okay, so the first thing is to make use of the concept that this is the turning point. So what is the concept for turning point? We must do a dy dx. So in this case, this will be 3ax squared plus 2bx plus c. All right, so since minus 2, x equals to minus 2 is a turning point. So dy dx when x is equals to minus 2, it should give you the gradient 0 because it's a turning point. All right, so we'll sub it in. Okay, so this will be 3a times minus 2 square plus 2b times minus 2 plus c is equals to 0. All right, same thing, dy dx when x is equals to 1 must also give you 0 because this is the other turning point. So we'll sub in 3a times 1 square plus 2b times 1 plus c will give you 0. So over here, we have already created equation 1 and equation 2. Okay, so how we need, as I mentioned just now, okay, we need 4 equations. Okay, so how we are going to form the other 2 equations? All right, a lot of students will miss out on this, okay, but the simple fact is we can use the coordinates itself to form the equation. All right, so when x is equals to minus 2, y will be minus 27. All right, so we can sub it into the main equation. So this will be a minus 2 cubed plus b minus 2 square plus c minus 2 plus d, and this should give you minus 27. So this will be my equation 3. Followed on by the last one, which is a 1 cubed plus b 1 square plus c 1 plus d will give you 81. And this will be my 4th equation. So once you have this 4 equation, very simple. You can just press your GC, but in this case, it's 4 equation, 4 unknown. Okay, so once you press your GC, the GC will give you the answer straight away. A is minus 8, B minus 12, C 48, and D 53. Okay, simple. All right, so if you are required to form systems of equations for the other chapters, okay, just simply apply whatever knowledge that you have for that chapter. For in this case, starting point, so you just set dy dx to be 0. Okay, form the 4 equations and you can get it. Okay, the next part, hence find the coordinates for point C on this polynomial such that AC is parallel to the x-axis. Okay, so one way is actually to draw the graph out for visualization. Okay, but for me, okay, sometimes the graph is not really important. Okay, so what do we have here? So today, all right, AC is parallel to the x-axis, meaning to say that it must be a horizontal line. Okay, so I'm just going to quickly randomly draw a graph. So if let's say this is my point A, which I know. Okay, the coordinate is -2, -27. All right, so C, okay, without knowing, C must be somewhere here. Okay, it doesn't have to be correct again. Doesn't matter to me, because what I just need to see is that AC is a horizontal line. That is the gist of this question, because it says that AC is parallel to the x-axis. So if AC is a horizontal line, meaning to say that if you look at A, the coordinates is -2, -27. So therefore, you can be very sure that this horizontal line has the equation y equals to -27, which also means to say that the y coordinates of C is also y equals to -27. So we are going to use this fact to solve the question. All right, so if you use the equation, which is y is equals to -8x cubed, okay, sub everything in, 12x squared plus 48x plus 53, what you want to know is when y is equals to -27, what is the possible x value? So sub it in, use your GC to solve it. Okay, can use your cubic solver, same thing, PRYSMLT2 to solve it. All right, and we can, from the GC, we can get x equals to 2.5 or x is equals to -2. So of course, this is your solution because this itself is already point A. Okay, then so hopefully you get my point for this. Okay, a lot of times we don't really need the actual graph. Okay, what we need to do is just have a sketch for us to visualize. Okay, Ken, so that's it for this question. All right, so let's move on. Okay. Okay, now we are going to come into another category of question. Okay, this category of question actually is something different from the previous one. Over here, we are going to face a very different scenario. Okay, whereby we have more unknowns than the equations. An example of it will be 3 unknown, but we only have 2 equations. Okay, so we are going to look at this scenario. 3 unknown, 2 equations. So how are we going to solve it? Is it even solvable? The answer is yes. Okay, but of course you need to do some interpretation. You cannot just fully depend on the calculator. Okay, so quickly let's look at this question. So we have a businessman in Australia who stayed in 3 different cities throughout its trips. Daily expenses incurred for each cities are shown. Okay, accommodation, transport, meals, city A, B, and C. So be careful over here. Okay, to read this, all right, we have to look it in, is it in column or in horizontal? Okay, that's the very first question that you need to ask yourself. All right, so you have to read it in horizontal because city A, city B, and city C. All right, Ken? So in horizontal form. Okay, so the businessman record the trip indicated a total of $160 spent on the accommodation, $360 on transport, and $350 on meals. Okay, by considering the number of days the businessman spent in each city, show that he has made a mistake in the records. Okay, so the clue has already been given to you. They ask us to consider the number of days the businessman spent in each city. All right, so we will let X be number of days in city A, let Y be the number of days in B, and let Z be number of days in C. All right. So in fact, at this point, we realize that we shouldn't be reading the table in horizontal form. Okay. In fact, what I've said just now might not be appropriate. Why? Okay, because of the values that is given to us. Yes, CTA summarized in horizontal form, CTB summarized in horizontal form, CTC summarized in horizontal form. But what we have here is the total cost spent in each category. So 1560 on accommodation, 390 on transport, and 350 on meals. All right, so we actually have to summarize it vertically. All right, so it's okay to make the mistake. All right, at least we know that there's two possibilities of reading the table. Okay, so let's form the first equation. All right, so this will be 430 times x, okay, spent in CTA, plus 250 times y, spent in CTB, plus 230 times z. And this will sum up to be 1560. All right, this will be a first equation. Next, 100x plus 120y plus 150z, and this will be 390. Lastly, 90x plus 100y plus 120z will give you 350. So 3 equations, 3 unknowns, plug it into your calculator. You should get x is equals to 3, y is equals to 2, and z is equals to -1. So is it correct? The answer is no. Why? That means he must have made a mistake in the records because of the z value. Okay, z is the number of days. It cannot be negative. All right. So therefore, because of this, he has made a mistake. Okay, let's move on to the next part. Upon checking his records, he is certain that he only spent 1590 on accommodation, and he stayed in Australia for only 5 days. Okay, so in this case, we are given 2 new sets of information. Okay, the previous set is all invalid already. So we can still use the same variables x, y, z. So today we know that x plus y plus z is equals to 5, right? 5 days. And we know that 430 times x plus 250 times y plus 230 times z, in this case is going to be 1590. So today, using the new set of information, okay, because we do not know where he went wrong in the previous set of data, so we can only be sure that it's this two. All right, so how can we solve for x, y, z? Is there a possibility? Is it even possible to solve for x, y, z? Okay, how can we do it? So in this case, all right, you can first put this all in your graphic calculator, because the graphic calculator can also accept the scenario whereby you only have 2 equations and 3 unknowns. Okay, so go to the same application and key in 2 equations, 3 unknowns, and key in everything as per normal. But today, the GC will show you this solution. X is equals to 17 over 9 plus 1 over 9 lambda. Y is 28 over 9 minus 10 over 9 lambda. And Z is equals to lambda. Okay, so for this special case whereby we have 2 equation, 3 unknowns, we have this solution. How do we interpret this solution? This solution actually means to say that there is infinite possibilities. How do we then generate? So for example, because Z, we'll start with Z because Z is lambda. So if we can just set Z to be anything. In this case, we can start with Z equals to 1. So if Z equals to lambda equals to 1, we put in to the Y value 28 over 9 minus 10 over 9 times 1, and this will give us 2. All right. And then continue. If we do it the same for x, we will get the number 2. So we can generate this value continuously. Put z equals to 2. Y will give us 8/9. And x will give us 1/9. So z can be anything. 3, 4, 5, 6, 7, 8, 9, 10. So this solution that is shown in the GC is a valid one. It simply tells us that there is infinite possibilities. But today we only choose z to be integer values because of the nature of this. It's the number of days. So when we meet with this kind of question, it becomes more of a guess and check. We can sub in any values to z. We can sub in any value that I want. But we can only choose one solution. So what is the most probable solution here? Okay, because don't forget, all these equations are possible. All these equations will satisfy 1 and 2. If you add them up, it should give you 5. If you multiply them with the constants, you give you 1590. But today, only the first one will satisfy. You can generate as much as possible, but you realize that only the first one will satisfy. Because the first one are all integer values, 1, 2, 2. So only the first one satisfies my criteria. All right, so with this, you can use the first value here to calculate the amount spent in CTA, which will be 430 times 2 days plus 100 times also 2 days, correct? Yes, plus 90 times 2 days. Okay, so today to compute this, again, we have to read it in the horizontal format because I only want the spending in CTA. So CTA is all 2 days. So this will be $1240. All right, Ken. So hopefully you understand my point in solving this kind of question. It's not that it's not solvable. In fact, in a lot of real life problems, we are faced with this kind of question, whereby we have actually more equations, more unknowns than equation. Okay, we can still determine the possible scenarios. Okay, Ken. All right. So okay, let's move on to the last question. So the last question. Oops. Can I have this? Wait. Okay, let's move on. Okay, let's move on to the last question. Okay, so this last question will also be similar to what we studied just now. Okay, just have a feel of what this whole thing is about. All right, so same thing. We have a factory manufacturing 3 different bracelets, A, B, and C. All right, the tables below show the number of white beads and pink beads for each bracelet required. A total of 70 white beads and 52 pink beads are used per day. All right, so how many bracelets for each design can be made? So again, straight away, we will let the unknowns be the bracelets of each design. All right, so oh, okay, actually we don't need because it's already written here. Okay, so the question naturally started off for you, let the number of bracelet A, B, C be X, Y, Z respectively. Okay, so we are going to form the equations, all right? Okay, because of the fact that there's 70 white bits and 52 pink bits. So it will be 4x plus 6y plus 3z. And this should give you 70 white bits. This will be equation 1. And we have 4x plus 3y plus 4z is 52 pink bits. All right. So again, we are faced with this situation whereby we have 3 unknowns but only 2 equations. So don't need to care. We just use GC. All right. plug it in, and we'll get the solution from the GC as this, minus 5 over 4 Z. Y is 6 plus 1/3 Z. Z is Z. All right. So today, again, Z is Z. Z can be anything. All right. So there can be infinite amount of solution. All right. So, but there's no other constraints for this particular question. So if I used a guess and check method, so if I let Z be equals to 1, Y will be 6 1/3, and X will be 17 over 2 minus 5 over 4, and this will give you your 34 minus 5, it should be 29 over 4. Okay, so but we do know that this solution is not possible because X, Y, Z is the number of bracelet and it has to be integer values. So we have to continuously generate, but this is going to be a bit tedious because it's just guess and check. If you don't believe, you can try. Z equals to 2, it will still give you some non-rational number or some fraction. Z equals to 3 will also be not integer values. Z equals to 4, also not. So we have to use a bit of logic or use a bit of observation to analyze this equation. So the problem here is whatever I use Z as, it should create integer values for X and Y. All right, so just look at Y itself first. Okay, if you look at Y, all right, if you look at Y, how can I make sure that Y will become an integer value? Okay, so the simple answer to this is Z must be a multiple of 3. All right, multiple of 3. So this sets the first criteria for Z. So the intelligent guess will be we try to put Z as 3. Okay, but we realize that if we put Z as 3, all right, it still doesn't work out for X. All right, so of course we go on to the next one, which is Z as 6. So if we use Z equals to 6, all right, we can complete the question by getting Y to be 8 and X to be 1. So this will be the probable set of solution for this. All right, so what's the purpose of this question? The purpose of this question is that sometimes we have to look into the equation itself or the solution itself to analyze it, all right, in order to intelligently generate the solution that I want. All right, Ken. So if not, that's it for today's short lecture. Is it short? I'm not too sure. Okay, thank you so much for spending your time to listen to me. Continue to have a good and safe week ahead. I will see you again next week. Thank you so much. Bye.